Hello everybody, welcome to Rocket Lasso Live Season 4, Episode 11. I don't have any special news or announcements or anything, so if you got those questions, start posting them in. Scott, I don't know if you're around. I know you've been posting some questions in the Slack channel before the show starts, but essentially I only want to check them out during the stream, like live. I don't want to see them ahead of time or be pre-prepping, and it's always for the people who actually get to be here live, so I'm not sure if you're here, but keep that in mind. Anyway, if you are posting or if you have a question, you can just type out the question. If you are linking to some cool animation or something, then you have to make sure that I can get access to the artist or studio, the name of who made it, so we can give credit. And for the most part, that's it. Make sure that you call out the effect or time code, because if you just do a link and it's like, oh, it's somebody's reel and there's like 10 different effects that are really cool. It's like I'm not going to pick one. I'm trying to answer specific questions that everybody has. So anyway, that should cover everything. Dim, thank you very much. Yeah, I did get a haircut. And then in Chicago, we've got like a crazy heat wave going on, so it's crazy hot here as well. So avoiding going outside. But anyway, that should cover everything. Brawley is asking about the spline tools and if they're going to be launching the utility splines. I did start putting together the demo scenes for, essentially I'm prepping it for shipping. So I'm actively working on that. So I don't have a date yet. Actually, I did put a date in the calendar, but I can't be 100% sure. But soon, very soon at this point, it is a plan. Anyway, we got some questions popping in, so I'll switch to the correct screen so I don't forget. Dean came in with a first one. And let's see what he's got. Mute the tab. Pull it over here. So, illegal? Inspired by something else, but we have that's cool looking. It's from Blender, but we've got a ever-increasing spiral, and it gets really thick at one point, which is interesting. How would I go about doing this? It's pretty cool. The funny thing is, I think we'd have to use one of my plugins to do it. I'm trying to think of how I would do it without a plugin, but every time I think of what I would potentially do to make it work, it ends up needing a plugin. I can think of two different ways of doing it, and one would be using the utility splines, which we were just talking about, which aren't available yet. So I wouldn't want to do that, but I guess we can ignore the smoothing part. So let's try and do it without a plugin, and then we'll do it with a plugin. So we'll just make a helix, give it, I do want the spiral, but no height. Okay, so we get the spin. Let's have it spin around, I don't know, 4 times, and give it a little more radius. Okay, so we get a nice big spiral. The subdivisions always end up looking a little janky near the origin point, but that's just what it is. Now, the tricky part here is we need this to get some thickness. Technically, there's a couple different ways I can think to do it, but let's make a rectangle spline. I'm not sure this is the best idea, but let's set that to, I'm not sure what orientation we want, but let's say X. Let's do 1000 by 10. It's going to need to be a lot more than that. So let's just immediately jump it up to 10,000 and create a deformer. Said deformer will be the spline. Is it just a spline deformer? I thought it was called spline wrap. But did they maybe change? Oh, yeah, one below it. Spline wrap. So feeding spline wrap into the rectangle. It's not going to look very good out of the gate, but we should be able to say along X, which it is. Go along the helix, and it should try and spiral it around, but right now it's not subdivided. So I'll change that to be a subdivided spline, and now you see it is subdivided. So now we get this nice spiral going across, and looking back at the reference, essentially that's giving us this nice small inner spiral. And then the thought is making a second rectangle And the second one will be thicker, and I'll make it just thick enough so that those aren't colliding with each other. It's getting a little bit messed up in the center. I'm just going to ignore that. I mean, we could increase the inner radius a bit. That we might be able to push that just enough to not do it, but now we're kind of losing the spiral. So we could do it. We could if we wanted to. Okay, now that we've got those, I'll hide the spline wrap. So you can see we get these two different spirals. I'm specifically interested in this wider one here. You see we get this nice big fat spiral going. That should only show up in some places. So if I make a rectangle and lie it flat, we can make that super wide and give it a little bit more height and move it up exactly 500. So now you can see that that's going, well, now we've got this rectangle that's cropping off part of that and creating a mask, which hides in this menu. I want to take this spiral and this and only show along Y, and this is where the union happens. I can say A subtract B. This would actually B subtract A. Actually, no, I guess it would be where they intersect. Nope. And. Yeah, sorry. And so now you can see I've got this back half of the spiral. And I'll pull this down below. And then we've got this secondary line that looks like that. We might need to offset it a bit. Is that difficult? We might need to have the second one be based off a slightly different helix. So if I tell this thin one to follow this other helix, and I spin the other helix a little bit, I should be able to get those to offset properly. So you can see it's lined up kind of a little bit more on the origin, like that. Okay, now let's just call this helix thin. This will be helix thick. And this one we'll also just call this rectangle thin, rectangle thick. And we need another mask, so duplicate that. And this one will be fed the first. And then even this isn't a bad idea to just call that like, spline mask thick. And now this one will be merging the thick and thin just to stay organized. So I can drop that in and say that this mask is actually the union of the two. Excellent. So yeah, now you can see that I think we've got kind of the basic shape here, and then the animation would hopefully be relatively straightforward, where we're yeah, I think that should automatically just work. I should be able to just make a null, and oh, nope, those are not refreshing. What if I manually spin it? Okay, if I manually spin it, it does, but if I spin the parent, it doesn't, which is interesting. We need to link these together somehow, which isn't going to be too hard. And I want that to constantly spin. We could deform it. I do like... let me think of how I might do that. I think we could just drop a plane into the thin and give it a time. And it is not going to affect position, but will affect rotation. I don't know which one, so let's say 720 on the first one. Turn on deformer, and then let's hit play. Let's look at the spline and see if it's doing anything. No, it's not. Should be deforming. Those are not doing anything. Point object. Oh, that's weird. It's refreshing very randomly. I'm thinking something about this setup it doesn't like. So we'll go less fancy. It seemed like just spinning it was okay. So I'll just keyframe it. So Control D, animation linear. And I guess we do both at the same time. So at the beginning, I will keyframe all the rotations because I'm not sure which one I want. And at the end, we can spin it 360. Should be really all. Honestly, we probably don't even need to do 360, but 360 for sure will perfectly loop us. Keyframe again, and then make our animation 1 frame shorter. So that should be a perfect looping point. Hide the original spline, and if it's refreshing properly, then we should get both of those kind of spinning. Oh, it looks like we want to spin the opposite direction. So I got to select those both again. And they, the way I did it, I can't easily change the number because they're separate. So I'll just manually spin it the other way. So we want to go get rid of that 360 and then go all the way to negative 720. And then keyframe that. I think I did that right. So yeah, so now that's spinning in. Now, in the reference, it was a little bit more zoomed in, so we wouldn't be seeing that outer one. That's kind of like disappearing. And now you can see we get this infinite spin. And maybe that swirl in the beginning wouldn't quite be there. But kind of ignoring that, this could be fed through an extrude. Obviously, and we get some nice geometry. So yeah, we get the extrusion. That should all still be animating just fine. Not exactly the fastest thing. Those masks are doing probably a lot of work, and there are quite a few subdivisions. So the matrix might be doing a lot of work to calculate that. Potentially, we could speed it up by grabbing the two rectangles, and we don't need quite so many subdivisions. Yeah, significantly faster then. So yeah, we get those spinning. And yeah, besides that, I'm not sure the way, let's look at the reference. The, there's a really nice swirl that happens in the beginning. I'm having trouble thinking of how I would super specifically do that. Obviously, it's spinning faster. Maybe it just has a little bit more initial radius. In the chat, Jay Hunt is asking, how do you ask a question? You just ask the question, you can type it out, or you put the link in there. Just don't spam it, and I'll try and keep an eye out. And I do like tackling questions from people who have never asked one before, so I'll keep an eye out for it. Anyway, I think that theirs was spinning significantly faster, so I will, let's pull this back to like 30 frames so it can go way quicker. And yeah, so it's going to be quicker now. And we could grab both of these and increase the inner radius a bit. Yeah, maybe something like that. Let's see what that ends up looking like. Okay, better, different. Those two kind of offset from each other, but the initial one is offset. I wonder if it needed to be offset. Why did I offset the first one? I can't even remember. Because that one's pre-spun a little bit. I guess I did to make it match. Yeah, we could change the radius, but I changed the radius. Yeah, that's fine. But anyway, I like the way that looks. The one of the other things that makes the reference look really nice was that these edges were very smooth, and that's where I was kind of going where... well, let me save this as the no plugin version. Double helix spiral. And then now we'll immediately save it as the next version. And we'll say utility splines, but nobody will have those. But anyway, just another good example of the upcoming utility splines. I can feed that into smooth. So now you see we've got the spline, and via the parameters here, I can add smoothness to it. And you can see we can get those curves in. And even you see that I've got that little kind of divot there because it's not perfectly lined up, but the smooth is going to do a really good job of just sort of erasing that out from there. And even on top of that, if I double click on the smooth, and you see we get all these subdivisions going. But I can say, you know what, we need more for it to look really smooth. So I can say subdivide that by 1. So you can see it's doubled the number of points. And now as I put an iteration or two, there were more points for it to work from. So it kind of smoothed everything out overall. And now, you know, everything else should just follow through. So I should be able to turn that back on again. And I can see how nice and smooth everything looks. And that's just going to be updating as it goes. So now we've got the nice smooth out edges there. That should be helping as well. So yeah, that's using the utility splines to get that curvature in there. But yeah, very cool, kind of cool, nice, clean shape. And there's a lot of opportunities to only show like parts of that. The mask, this mask here could have been offset a whole bunch. So maybe that's only taking up a smaller percentage, and you could be doing different thicknesses in different spots. And you know, the whole rig is like simple and robust, so that should work. And you can see it's actually, well, I like the way this escapes out from that initial shape, but I kind of wish it was already in there when it went. But yeah, nothing to worry about there. So yeah, that was that was doing it and just adding the smoothing in via the plugin. I can't really think of a way of doing that without the plugin to smooth out those edges. And then I had said that I had a completely different thought of how to approach it using Slicer, which maybe isn't a good idea. We might need like a lot of subdivisions, but at least it would be a plugin that people do have access to. The is it a good idea to even pursue that? I kind of just want to, maybe we'll modify it a bit. I don't want to lose that stack, but I'm going to turn it all off, and let's just look at this original. I just want to look at one of the helixes. So we got one helix here. And what I'd like to do is, and we're going to be using a plugin for this one, I'll make a plane. And what I would like to do is do a bunch of deformation on it. So let's crank up this to be 100 by 100, and we shall deform it with a plane effector. Plane effector will be deforming the points. They will be pushing up on Z. I'm going to not be subtle, so let's push this up to, I don't know, 500. So yeah, pushing it up a whole bunch. To begin, well, we can just immediately drag that spline in, and you can see that actually the spline does a pretty cool spiral because it's set to curve. I wasn't really anticipating that, but that's kind of cool. Going into remapping, I can... maybe this isn't going to work the way I thought it is. But anyway, I'm going to carry on. Invert the entire result. So now we kind of get this pyramid shape. It kind of gets weird. I thought that would be a little more linear looking. It definitely is not linear looking. The spline should have been linear. It's interesting. I wonder what that cut up would look like. Well, how do I put this? Well, what I want to do is feed this into Slicer. So let's even simplify. So now all I've got is that spline, and it's deforming the plane. So if we make Slicer plugin, and I drop that, I could drop it inside. I'm going to remote link into it, and then we can hide the original object. So I would like to auto scale. So now it's matching the shape, and then probably scoot it up a little bit more. So you can see I am catching the spiral. I was just curious what the end shape would look like, because it's making a whole bunch of different cuts. The Slicer does have built-in smoothing because we knew the plugin wasn't out yet, so we kind of put it right there. I'm going to turn off the preview cuts. So yeah, actually it makes kind of a weird shape because of the way the spiral translates through the geometry. So that should still be spinning, but yeah, it's not what I would have anticipated. And it's more about, I was thinking of the way this hill would look wrong, where I wanted cross sections. It would be a spiral. I don't know. Am I wrong in what the original thought was? I just want to spend a little bit more time here. Get rid of, well, I'll turn that off temporarily. Feed in a spherical field. Scale it up. Pretty much get to the edges. Let's give it a full remap fall off so you can get all the way up to the top. And now if that helix was adding on top of it, let's subtract from it actually. And do I change that to, yeah, I think I changed that to a radius. So instead of being a curve, I'll set that to a radius and increase the radius. So essentially what's happening is you see we kind of get this bumped spiral, each of them traveling up. So this was what my original thought was, is that we'd really subdivide it and then kind of get this spirally hill looking thing. And it's not super clean, so I'm going to add some more points, and then potentially you could smooth it. Yeah, a little smoothing goes a long way for a shape like this. So yeah, just take those edges off a bit, and we get this nice spiral shape. going up the hill, very, very uniform in this particular instance. So then if I were to say slice that and hide the original, okay, that's a little bit more what I was expecting. So you can see we're kind of getting these softer spirals cutting through. And then in Slicer, I can say spread. I can pull that. Oh, wait, not that spread. I want spread. I want the spacing. I can pull the spacing back and flatten the whole thing. And now you can see we're getting a kind of similar shape as we get a bunch of different cross sections from it. But I don't think that that's going to end up with... Yeah, this is obviously not the same effect, but it's pretty cool looking. A little more smoothing might be a good idea. Those little islands are getting left over, but if you put too much smoothing, it's not gonna work. It's different. What's cool is you could get it morphing a bunch here. So for instance, if we go back to the hill, and I go back to the plane, and we deform it with something else, let's put in a random field. So now we get all this crazy like hills going up and down and getting all crazy. I'll say I would like to add onto the overall thing, and we don't need much. I'm going to pull it back and then just add some of this little up and down variation. In the random field, we can crank up the scale, and yeah, so now I can start getting these little individual kind of crazy ridges, and I'd like to give that a little bit of animation speed. So if I hit play, this is what the hill is doing. You see it spiraling around, but you can see how these little waves are kind of evolving as they morph through. We can increase the speed there even. And yeah, so those will be constantly changing and evolving. So as we go and we cut cross sections into it, and then flatten those cross sections, we end up with like these implied spirals, but these little islands are kind of drifting up and like in and out of it. So now we should get this nice swirl going, but it's going to be evolving because of the noise is changing. So we get these nice, this pattern that's constantly expanding out, but morphing and changing as it goes. Let's see, how much smoothing are we doing? Oh, not smoothing, that's smoothing. I want to do as little smoothing as we can get away with. And under modify, yeah, we have remove tiny, so I can, like, you see these like really, really tiny ones? I can actually change the threshold here and make those disappear. The overall size was smaller than this threshold, so I can get rid of all the ones that are kind of tiny and insignificant. And based on that, this can then be fed into an extrude. And yeah, so now we end up with this crazy bit of geometry. And you can see why I was thinking of this process. Extrude. I really don't like the extrude being on auto. It sometimes flips upside down. And was there a single blip in there that I didn't like? I guess there's the reset one. We're not looping perfectly anymore because of the noise. And some of these lines might crisscross each other. So, but anyway. Yeah, so now we get this super crazy shape evolving and spiraling, and you know, a similar concept, but completely different way of approaching it. But I really love the technique of using Slicer to cut. You know, you make a relief, you make a landscape like this, and then we slice it up, and then you take that end result and do something with it. Because, yeah, this crazy organic spline layout. I don't know. I can't imagine how I would approach something like this if we couldn't do it with this technique. But anyway, if anybody owns Slicer, I will save this as the next version. That one actually should be renamed with Slicer and save over. Sweet. Thanks for the question. Hopefully, you know, we did the version with no plugins, and hopefully that, you know, got you kind of where you were thinking. Okay, jumping back into the chat. Let's see what we got. JDC, you are north of Chicago. Yep, super hot up there probably, I imagine as well. David, thank you so much. Yeah, it does look like a Rick and Morty portal. Let's see. Dim, I'm going to keep an eye out for yours, but I want to jump on Jay Hunt's question because they're new. I just want to see if there's any follow-ups to this one. Okay, we'll definitely tackle yours, Dim, but let's click on J Hunts. Okay, muting the tab. Let's. Oh, it looks like it's just a still. What are you? I'll pull it over in a second. Let me see if you are. You want to know how to get the skin to rip apart, but this isn't animated. All right, well, I'll pull it over. The I was expecting an animation, but my assumption is like you see that we've got a skin on the front and then a whole bunch of interior stuff going on. So I'm assuming that's what you mean. This is Car Life. Oh, and I see that you asked a question right there about how to do the skin rips. But like it's not animated, so I feel like that makes it significantly simpler. I don't think we need to overthink this. Let's move into the content browser. Go to where's the elephant? I don't want the elephant, but the elephant will get me to the right folder. You can always search for something you know and then say reveal in browser, and now I'm in the proper folder. And yeah, it would have been hard to find objects sculpting base meshes. But anyway, I went here just so we can go and grab a reasonably detailed face. And it's a sealed off volume. So you can see, okay, this is just a nice simple mesh for us to work from. Okay, so as far as looking at the reference, I think you would want to build interior detail on the character. So I'm trying to think of what I would do to make interior detail. I mean, we can have a little fun with some parametric modeling with the node stuff. So I made a copy of it, and so this is the one we're looking at. And then let's just assume that this is going to be like interior detail. So what are some things I'd want to do? Well, let's move into nodes and go into geometry modifiers and shrink this down so we can see everything. The first thing I might do is smooth everything. So let's try smoothing this out a bit. I kind of hate that. Maybe a little bit. I just wanted to take the edges off a bit. Hopefully that doesn't make anything pop outside of the model. And then let us go to selection and do a random selection. And from that random selection, we will then modify again and delete. So we should have randomly selected a bunch of things, and now I've deleted a bunch of things. We can change this random selection. I could have there be more or less. So let's just have there be actually very little. But that's just going to be slightly in from the edge of the skin. And I would like to then extrude it, or we could do a solidify. Let's do an extrude. So I can say extrude, all of them will be extruded. I'll say I would like it to go -5. And 5 is actually a lot, although it doesn't look, I mean, I always, when I see this type of thing, I'm always like, oh, well, that's bad. But, you know, it's not necessarily bad. But anyway, let's just say -0.2. Maybe we can even go up to -1. And we can do offset variation of up to not quite 100%. And now we get all those extruding in. We can say use islands, so they will be grouped up properly together. And we can create caps. So you can see we got all these little, you know, every separate piece is extruded slightly differently, and they're pushing in. So that's just one random bit of detail for the interior. So I could duplicate that. And now we can go do something else. So in this case, I've got a copy. We're doing a random selection, but I'll go back to selection and say, okay, cool, but I would like you to invert the selection. So now we've got, I'll turn those off. How do I show this? I'll create a new redshift standard material. Just throw it on there so we can see at least a little difference. I made some presets for myself, so I'm going to make a copper. So yeah, you can see that we get these two separate ones. So now we inverted the selection. Oh, and I can delete. So now all we're seeing is these remaining ones. And how would I like to do it? So many different options. So we inverted, deleted. Let's say we want to, again, do another random selection and then delete again. So you can see I've randomly deleted more. I would like the random selection to be a different seed. So you can see now I'm randomly deleting different pieces there. And we get these nice little remainders. I kind of want to push those all in, but I don't think there's any automatic way of kind of doing a offset per polygon. But what we could do is say, I would like to extrude them in, but don't create the caps. And we did delete, so we should probably select them all. So I'll say selection, select. And after deleting, I'll say select all the remaining polygons. So I put a select in, I said all. So I'm selecting everything. And then I'm extruding them. And that means only these interiors will be selected. So I'll say, okay, extrude, you're doing a good job there. Some of those could actually be even more offset. So I'll say -2. And here's our offset variation. So, they can be a little bit, they could be almost none. And now I should be able to invert my selection. Okay, let me show you. If I make another delete right now at the end, I think it's going to delete the caps. Yeah, you see all we're left with is the walls. So instead, before that delete, I'll invert the active selection. So now those walls of the extrude got deleted and we're just left with the extrusion pushed in. So you can see I've got this kind of inner gold layer, and this inner gold layer are by definition polygons that were not on this outermost layer. And then, just for fun, we'll just do one last layer just to get some additional inner detail. I'm trying to do this with no plugins. So we're smoothing. I don't want to do random selection. I'm just going to delete everything from here, and we'll just go step by step. Let's duplicate that material again. This time I'll make a aluminum. So we're smoothing out, and then I would like to select all. So I'll duplicate that select, and then extrude, which should extrude everything inward. I'll extrude even more. So -3. So that's all pushing like really far in. You see we get this kind of deep interior. And then if I was inclined, I could select the invert and the delete. And that's going to delete the, select all, extrude, invert, delete. I thought that would work. Smooth point, select all, extrude. The extrude should have only been the interior. Maybe the extrude. Oh, it's a volume. Yeah, okay, that makes sense. The extrude, that worked properly. I forgot that. I thought it was a shell, and it's actually a volume, so it just that does correctly work. Yeah, if we want to push it further, we could, let's make a second extrude, and this time, actually, let's do a random selection. And we'll randomly select some different polygons. Who knows what they're doing, but now I can extrude, and we'll have those extrude -1, and it's just going to give us a little bit of interior detail. If we are inclined, we could subdivide this once, and once again, we could do it parametrically. Of course, we could put the entire thing in subdivision surface, but while we're here, why don't we put it into a, what do I want, a modifier, and we can say smooth geometry. And actually, that is not what I was expecting. I don't want smooth geometry. I want subdivide. Subdivide geometry. Wink. So what's cool about the subdivide is by default you can get a subdivision more like this. So you can see we could do that where like I've got extra tiny detail there, and we could extrude those again if we wanted to. But I can just turn on smooth, and it's going to round everything out. Actually, what's kind of interesting there is it's only working, the subdivision's only acting on the active subdivision, on the active selection rather. So you can see how I can like round out that interior, and we kind of get that weird transition from like a round shape to a kind of mechanical shape on the outside. It's creating a bunch of n-gons to do that. Now I actually want everything to subdivide, so I'll just say select all. And now that is going to smooth it all. Anyway, it's always interesting to kind of step through there. But anyway, all of this, the point of all of this was just to make some kind of crazy interior detail. Just a little bit randomly. So now we can go back to the original female bust, and did the original one? Oh yeah, we smoothed it. So in theory, that pulled them all in a little bit. So now I can pull this out, and the smooth isn't fully pulling everything in, and those is looking a little bit funky. We could delete that out. But I think that this one needs to get extruded in a little bit. So we're smoothing in, but I'm going to say first do an extrude of -1, no variation, -0.5. So it just pulls it all in a little bit. So now we should see that Did I do it backwards? Interesting. Smooth. Oh, extrude, then smooth. Let's smooth, then extrude. Then select all. No. That extrude is just causing trouble. That's fine. I guess I'll make an extrude on the outer one and just inflate it a little bit, just as a way of kind of cheating and getting around the whole thing. Let's push that out positive, get rid of the offset variation, and that needs to be real small, like 0.1. Yeah, I mean, we didn't do it perfectly to push those all in, but... Oh, and then we got that crazy silver nose, which is kind of not looking great, but we can always go back to the original geometry. So I could select the nose here and just be like, like the nose wasn't looking great, so I'll just delete that. And then, you know, once we get to this final one, like, it's going to look fine. Actually, it looks kind of crazy, so maybe, maybe not. But anyway, you get the point. You get the point. Okay, so we can go back to the skin layer. And to me, this goes relatively straightforward, where all we need to do is choose what parts are going to be shown. So if we make another, I'll make a duplicate here. I don't have a preset for like skin or anything, but and I don't know what my butter preset will look like. Let's just do plastic, keep it simple. So we'll do a plastic skin. But yeah, at this point, if you just want to see the skin, I can just start doing a selection. And if we were doing it similar to the reference, we just grab like these pieces here. If I want to follow some of the curvature of the model, and delete that out. And it's like, okay, now you can just see through the skin to all of the extra detail that we have going on underneath. So just by selecting little bits, we can get this techie looking section. And keep in mind, while we are manipulating the geometry, the extrude isn't active. It's just like any deformer. Those are acting as deformers. Select the eyeball. Grow it by 1. Delete. We'll see in through the eyes, of course. Grow again. Let's grow that twice. Wow, that one's a bigger eye. And yeah, you just go and sneak through the skin. The entire, if everything had gotten extruded inward a little bit more, that probably would have been a good idea. And maybe that original smoothing isn't a good idea. Yeah, I think if I turn off that smoothing, that's making everything better. Yeah, the smoothing was changing the orientation, so the extrude didn't work as well. Now everything's sneaking through the geometry a lot less. So yeah, you get this nice interior detail. What I probably should have done was made a material selection. But yeah, you can just see what we're seeing right through it, so it wasn't peeling per se. Making another duplicate with no modifications, if we make the selections, I guess it does want the extrude, but if we make a similar selection and invert it, we could have done this more parametrically, but I didn't. But you see now I've got this panel here, and that panel could be a different piece of geometry. So we could make that glass, we could give it thickness. Let's make a duplicate here, and I think I did make a basic... Oh yeah, glass. Okay, so I got a basic glass material, and I can drop that on, and I put it on the wrong object. Yeah, so now that should be transparent. We could give it some thickness really easily. There's a geometry modifier called solidify, and that just gives things thickness. So we'll give that I don't know, 0.2 bit of thickness. And it's all set up in Redshift. I'll give that a save. Peel, skin, techie. I'm saving just because I'm gonna hit go on Redshift, and you know I gotta be careful with that. I'm gonna search for .hdr, pull up a Redshift dome light. Don't search nodes, and now I do want to see pictures. And I don't care which one, just give me Alex's apartment. Boop. So yeah, now we got something to show. Turn off the background. Turn on our, I'll save it again, Render view. Turn off. I wish I could stop that from being there, but yeah, let's turn on the quick version. Let's go easy on that saturation and brighter. Yeah, so we can start getting all these interior details poking through the skin, set that up however we like to. We can see the actual transparency, like which should be, you know, refracting and whatnot, and then throwing some lights and whatnot on the interior. Let's make an area light. Put it inside. E for move. T for scale. Wait, is that an area light? Why is it? It's probably really big. Oh, yep, I was right. The head's really small. Okay, shrink. And yeah, we can start putting some interior lights in there. Yeah, so you get this kind of bright glow. I mean, I'm not trying to make this look pretty. Just doing some for instances here. Pull this back, start getting more glow on the inside. Put a couple different lights, some different glows, get some luminant material, get some subsurface scattering on the plastic. And yeah, it's just all about, I mean, in this case, I could be completely misinterpreting your question, because like it just, like I said, it just feels like, hey, there's some interior geometry and you delete part of the skin out. Potentially you do it with a selection tag, potentially do it parametrically like we did here with the scene nodes, or spend a whole bunch of time doing it super manually. I know I just did that. It doesn't want to show up anymore. I moved the window and now it's like, nope, not going to render. I don't like how it's reacting, so I'm just going to turn that off. But anyway, I think I kind of got to my point. Oh, this is something that I've had happen before. See, like I said, I'm always a little bit worried about getting Redshift going while the stream's going, because like I think it's upset about the viewport now. Like even if I open a new file, it doesn't want to show anything. Boop. Yeah, and I don't think I've ever figured out a way to make that pop back in again. I mean, we didn't lose anything, so I'll just close Cinema and open it again. Anyway. But looks like Jay Hunt is happy with that. So, I'll check YouTube. Ali, you cannot put links in YouTube. If you want to do a link, you got to go over on Twitch. YouTube just doesn't allow links. So, I don't know if you can see your own link there, but I cannot see your link. It says message retracted. But anyway, Dim had a question, which got seconded. And that's always a good idea. If somebody asks a question and you like the look of it, you can always say that you second somebody's idea. And that will let me know that people are interested in seeing that one in particular. So what do we got? Rafik, Anadol, quantum memories, probability. Looks like it's some sort of real life LED wall. The resolution of these pixels, let's see, did you call it a specific time? Dim, dim, dim. Oh yeah, okay, you didn't call out specific, but anyway, we're just getting these exploding. I mean, what it looks like is there is a painting, there's a static painting, and then it all starts exploding out. There might be some additional definition. It seems like, I'm not sure exactly what's going on. You see how the colors are morphing and changing, but there could be like video, like this could be a video underneath it, which is very possible. For the most part, this is as it goes to the resolution is going to be the tricky part, because yeah, this is going to be all about resolution. We'll do it with cubes because they're going to be quickest to calculate, and we'll make a bunch of tiny cubes that are 5 by 5 by 5, and we make a grid of them in a cloner, And we say that they should be 6 by 6 by 6. And now there'll be just a little space in between them. And we can set this to, I don't know, 55 by 55. So now we got, you know, pretty low resolution grid here. And we need to apply some sort of image or video to it. So to keep it simple, I'll set this to standard render, because now I can just create a default material, which can be anything. Let me go track down what's a good picture. We can feed in the picture of the rubber duck, maybe. So, hang on. Oh, my hard drive was spinning up. Rubber ducky renders. Let's grab a happy rubber duck. Yeah, go ahead, copy it over. And I didn't save the file first, so this probably wouldn't save in some super random location. Anyway, yeah, so the rubber duck's here, but honestly, I didn't need to make it as a material. You can make it as a material. I shall make a plane effector, which does not affect the position, but it will affect the color with fields. So in the fields, I would like it to get a shader field. The shader field will get drop down, bitmaps, and there's the duck we already brought in. So I can feed in the duck to feed through. Don't affect the position, scale, rotation. Instead, affect the color, and immediately you can see that get applied. It doesn't know what its orientation should be. And the default orientation is not doing anything helpful for us. So now it does go to this material is applicable, because what I'll do is apply this material onto the... Actually, we can apply it to anything, really. I could even apply this material to the plane effector, which obviously kind of doesn't exist as a physical object, but I can say, hey, project that material on flat. And if we go into texture mode, I need to make sure that that is applying at 90 degrees, T for scale, scale it up to pretty much match our grid. And now the shader field will not look at the custom shader. Instead, it will look at the color channel of this tag. And by referencing that tag, you can now see that it's been applied here. We get our nice pixelated duck. You get the added advantage of every single block is a solid color. So it's not projecting the image onto it. It's taking the color. I don't know if it takes an average of the color. It might, but it's taking, you know, one particular color, applying it to the entire rectangle, and now we get this final image. We'll save this because we're about to get into the world of dynamics. Painting, explode. Yeah, so now we make it dynamic. So turn off gravity, control D. We're going to be using bullet dynamics. Turn off gravity. And add a a bullet rigid body. And if we hit play right now, nothing should happen. I will make sure that these are calculating as boxes, as cubes. And now we need them to start blowing around in some way. The easiest thing would be, well, let's make a field force right away, because why not? Forces, field force. Let's have it apply 55, just a good number to actually show something. And that's, oh, it's in the cloner. That makes sense. I was like, why? What is that pattern? I don't recognize this pattern. And then we feed that a random field. And it's a good idea to increase your random field. I'm going to keep on increasing the scale until I start seeing some uniformity in these lines, which I think I'm seeing, but let's go even bigger. Yeah, see, now we're getting some uniformity to it. And give that a little bit of speed. Turn off the display, because that does take time to calculate. And let's even visually hide it. And hit play. And like they'll just all drift away. Now, if we increased our particle count a lot, then you can imagine you're going to get a lot more flow from it. Like everything's going to feel like it's separating and like drifting really nicely. This would be a good situation where you'd want to do like some proper like advection, like heat map type stuff, which we can't do in vanilla cinema. Like X particles, you could do that type of thing to get like extra detail in the direction it's flowing. You can see even right now that this is not the quickest thing to simulate. I'm already down to 3 frames a second, which is a little disappointing that the count is so relatively small. I think because they're dynamic, we cannot make it a multi-instance, but let's just give it a go. Oh, actually, it seems like we can. It gave us 1 extra frame a second, which is something. Giving this dimension would also probably be a good idea. There's no reason. I mean, it's going to start going slower, but we could put a second layer here, so it's like 2 layers thick. So there'd just be more volume once it starts breaking apart. Like there's more pixels underneath it to play with, and those could potentially be offset or changed in some way. Let's drop this to something significantly smaller. Yeah, you can see it breaking apart a little bit different. And, I think for the most part, this is pretty much what we were looking at. If you set this up in a box and you put some really nice lighting on it, and, you set it on a locked off position, then they're going to look like they're drifting out from the box. I could be missing a detail here. That's an interesting idea. Somebody's suggesting that distorting, I'm not sure if you're talking about me, but distorting it as geometry. I wonder if that would enable us to let this run a lot quicker. I guess the cubes would pass through each other, but it's just a completely different way of thinking about it. So I'm kind of curious. We might even want to keep this. I'm going to turn off dynamics and make a plane and make the plane be subdivided 55 by 55 and let's just scale things. I'll scale up the material, match that. Tell the cloner to clone onto an object. The object will be the plane. Clone 1 onto every polygon center. Now, by the very nature of dynamics, this will be quicker. I'm going to scale up the cube. Nope, stop it. I'm going to scale up the cubes a little bit to fill up the space. So you can see we've got all of our cubes, but these are multi-instances, which tend to run pretty quickly. So if we deform this plane instead of letting all the dynamics move, then it could probably run significantly quicker. And even this could probably run via a bunch of different systems if we were so inclined. Could change polygon counts and whatnot. That's a little worrisome. Let's start out with a simple bullet soft body. And to begin with, I'll say don't self-collide, which will automatically run really quick. And everything else should still kind of be set. And I kept the field force. So the idea here, let me show you. The idea here is I should be able to hit play here, and we're going to see this cloth start to deform. Still going surprisingly slow. I swear. Maybe my computer's dying. I don't know, because I feel like this should not be anywhere near as slow as it is. Like, we do not have that much geometry going on here. You know what? Well, just for fun, let's put the simulation cloth on there instead. There's a couple reasons to be careful with that. First of all, I need to make sure to put that on CPU. We need to turn off the gravity. The field forces are not going to work with it, unfortunately. But we can add a turbulence in there. And now let's just see what kind of speed we get from that. Okay, you can already see that's running like way quicker. So let's do that. What do I want to do? Turbulence scale, we need to give it some scale. And then probably give it a little bit more oomph. Make that bigger until there's a kind of consistent thing going. In the cloth, I'm going to say it's very bendy. So now it's allowed to bend. We can give it a little bit of stretch as well. Double thickness I don't really care about. The turbulence is, I feel like acting a bit strange. Is it just averaging itself out really, really well? Maybe. It's behaving way too consistently. You see how it's like actually doing a really nice job of just kind of ambiently being here? So maybe it's just the cloth doing a really nice job of kind of being coherent. I did say I gave it maximum bendiness. Let's make it even more stretchy. We'll say don't worry about thickness. I'm almost having trouble. It's being too coherent. I gotta make it really stretchy. How many? Okay. Okay, if I put like really big numbers in there, it finally does start like going nuts. But even here at like 1,000, you can see it's like doesn't want to stretch too much. But there we go. That's now allowed a little bit. Let's say really bendy. So yeah, there now we start getting a little bit of kind of crazy flow wiggling around and whatnot. So that could be fun. And because we're in cloth, we do get some fun options. You might want to subdivide this a little more. I'll say 77 by 77. Make it editable. And let's select all. UK to shrink, UI to invert, and now I've got the entire outside selected. And we can go to dresser and say fix those points. So now all this stuff will happen, but the outside is locked in, so we can get all this kind of crazy swirling going on, and the outside is going to keep it locked in, which is just nice, running pretty quick for us overall. Okay, now turn back on the cloner. These are getting cloned onto every single polygon, and the color is still being taken on from this projection. I think the texture will stay stuck, but I'm not 100% sure. Let's hide the cloth and hit play. And yeah, that's running pretty dang quick for the overall rig because we're using a multi-instance, and now we get this nice kind of thing flowing around. What's kind of cool too is in theory, if I turn off the turbulence, the image is going to do a pretty good job of putting itself back again. So it does open up a couple of additional opportunities. And, you know, the cloth does come with a lot of natural advantages. We don't have field forces, but it does enable us to lock these corners in like trivially easy. Something I would like to do here, a little dangerous, but I kind of want to see what happens if we let it tear. But there's a good chance that when it tears, the clones will kind of freak out. Like they might pop or something. I'll save this. I think it's just a superior version right now. I know that those cubes will pass through each other, but it more goes to like we could make so many of them and make them so small. Even now, I guess maybe it wouldn't be more. I was going to say we put them on polygon or on point centers, but I don't think that would really change too much. Oh yeah, tearing. Back into the new cloth, I'll say that it is allowed to tear. And let's leave it at default. I just want to see with the amount of stretching and bending. Okay, you can definitely see that it is able to rip. Actually, it's almost perfect what I want it to be, like a, you know, a very coherent sort of ripping. Tearing guide, we could say that I want it to lean a little bit more. If I increase that, I think above 45, the cuts are going to be more likely to like make a harsh turn. We can only go from 0 to 90. Am I getting that wrong again? Because those feel pretty coherent. If I say 0, which one is going to make it more ragged? Now, see, that feels very much like along the seam. So maybe the other one was more ragged. Meh. Not something to super worry about. We could do some vertex maps as well, but yeah, that's some nice tearing. So now let's see what the cubes do when reacting to changing scenarios. Actually, it looks like they do. Nope, no, dang it. It was so close. A lot of them look really good, but I can definitely tell up here. Do you see how those are changing? Although, is that because the index is changing, or is it because the image? Maybe they're not. Maybe the color isn't stuck the way I thought it was. No, I think it is stuck the way I thought it is. Yeah, see right there, you get this blue pixel like popping in. So unfortunately, even though it's doing a really great job tearing, I think the indexes are changing. And if the indexes are changing, then these cubes can't be perfectly stuck. The cube is stuck on a particular polygon, but suddenly the index changes where it's like, oh, there's a new polygon in town. So the point order has changed. So they can't perfectly maintain. You definitely see it on these blue ones, like kind of appearing and disappearing. But you can see here, like as that green drifts away, like there's actually, no, it did change color. Let's see. A lot of them are changing, but it's still tearing. So is the texture not sticking? I don't think we have all these blue pixels. That's what I don't trust. I mean, there's some blue there, but See, we start getting like blue right there. Maybe there is some blue in the image. I don't know. Is there a way of sticking the material? Because that's being fed a cloner, or it's being fed an effector. The effector is being fed a field. And the texture is flat projected. Maybe we should... Maybe I can apply the material here and then convert... I'm going to generate the UV coordinates from that. And flipped upside down. In this particular instance, I don't care that it flipped upside down. Oh, well, no, there's two of them. This is now UV projected, which means it is going to be stuck. If we look at this as a material and not a cloner, we should see that that material should be stuck to it because it's based on the UVs. So if that is what we are referencing, no longer as a flat projection, but as a UV projection, if this was going to maintain the color, this would be the only way that would work. It's hard to tell. We're getting some highlights, but it looks like it's doing a better job. That actually seems pretty consistent. Not that super important. Like, it's it's a ridiculous thing to like have these be tearing apart, but you see this whole thing eventually rips itself to shreds. But the initial couple frames of tearing are pretty cool. We could calm it down, obviously, by cranking it up to a higher level, but it's going to take longer for any of the rips to show up, if at all. Like, it just might never cross that threshold. It's very particular. Yeah, that could start a tear. Some random ones. But yeah, cloning onto it. It's fun. And we could subdivide this as much as we want. I wouldn't expect to get good playback kind of no matter what. And then you can obviously see that these cubes are like crashing into each other. There might be a way of like getting that to relatively not do it by... These cubes are currently about 4 thick. So could we tell the cloth to be, you know, I'll say 5 thick? And then, you know, is that going to kind of make them avoid each other? Because it can't fold over? And I don't know if the thickness does like half above, half below the normal, or if it's like all above or all below. It almost feels like some colors are changing, but I think it's just because we're rotating and catching light differently. But yeah, now these, you know, they don't seem like they're colliding too much. You know, a little bit, but they're not just like passing through each other randomly. Via the thickness of the cloth, I think it's going to be less inclined to tear because it can't bend as sharply because it's kind of bumping into, you know, its neighboring thickness. But yeah, that's a fun little alternative using some of the new techniques in S26. So I'll just save over that one because I think it's looking fine. So let's go and check the chat. Let's see. Leandro is asking, is there a way to simulate size like the old cloth system to grow and or shrink it? No. Sadly, there is not. I wish there was, because that was a really fun thing you could do with the other one. The only thing we have in this system is pressure, so we can balloon things and pressure it up and down, but that's not a overall scale. I'm trying to think if... And what that must have been doing too is like shrinking all the springs. That seems relatively straightforward. I hope that they can implement that in the future version of the simulation stuff. Because, you know, there's all these relationships between springs here. And then that rest length would just be the size of the spring. So it could be the springs push further apart or they shrink down. That is not going to be the case here. It's kind of my question would be, how much is it referencing the original model? If we release those stuck points, so now nothing is stuck. If I physically shrink the model as an object, it seems dangerous. We could morph it, that's a little safer. We could do it as a deformer as well. What happens if you use a plane as a deformer for points and I scale? Does that actually do something? No. What if I do on polygons? What it did? That's kind of weird. Feels like it's doing something, but what is that? That's weird. That doesn't seem right. What if we do it as an object? Whoa, okay. You can maybe do it as an object. So let's do an absolute uniform scale to minus 0.9. So it becomes tiny. Okay, so we're now deforming everything from the axis of the object to go down. So if we have this up, here's the original size, presumably. Yeah, that's what it's doing with nothing. So we'll let it go 40 frames. Keyframe that, and then over the next 100 or so frames, we'll scale it down. So independently, like not using the simulation system, but can the simulation system acknowledge the shrinking geometry? I kind of doubt it, but let's see. It should still be tearing. Maybe. Yeah, there's some tears. Okay, so it should start shrinking right around now. It should be pretty blatant. I'm not feeling any shrinking, but let's give it some time. Actually, it does kind of feel like it's collapsing in a bit, doesn't it? Maybe that did work. Whee! Okay, interesting. Let us make that more extreme. Have it happen earlier. Have it happen quicker. Have it stay there for a moment, and then have it grow back up again. Okay, let's see what that does. Okay, so it's going to start shrinking now. Okay, it's acknowledging the deformation shrinking. It doesn't seem to view it as energy, though. Do you see how it didn't follow through with it? Oh, this doesn't count. This doesn't count at all. This is a series of deformers. This is behaving as a deformer. And expose it is simulating on generator. This is just deforming the geometry, and then this is just deforming that deformed geometry. So that's not at all kind of what we want. I'm going to trick it, maybe, into doing the proper order that I want. So now we're saying, well, plane, deform this plane, and then Dynamics, look at the resulting geometry and run your simulation on it. I wouldn't be surprised if we just crash, but let's see what happens now. Because what we really want to do is like, oh yeah, do you see how, oh, look at those pops. So as it's shrinking, it's constantly kind of resetting that geometry. Whoa, it did explode in a crazy way. Like almost everything ripped. So, a couple of things look cool there, but I think it's not super working. Because, yeah, you see how it keeps on like resetting, like all that deformation is resetting, because it's being like, oh, my incoming geometry is fundamentally different, just reset. But then when it explodes, oh no, that's, okay. It suddenly started being coherent when there was no changing deformation, but as soon as the keyframes came back again, like during that little period right there, that's when it started exploding. But then as it continued beyond that, you see it just repaired itself again, because it can't have the incoming polygons change, even though we're not changing the point count, we're not changing the polygons, we're just changing where they're positioned. It clearly cannot acknowledge that. And then let's move that back down. And this time, I thought, well, this is when does it simulate? It simulates on generator 100. We could, I don't know at what time a deformer calculates. There is no, it doesn't expose that setting, but there is a number. So what we could do is try and like tell this to calculate even later. So I'm just going to add a couple of zeros there. 499 is technically the highest. But anyway, we're now saying that in theory, this cloth tag should be like the last thing to calculate. But even that might not actually count, because you see it's not deforming. There's no energy. It's not acknowledging that as an input. So I still feel like this tag, because it's a tag, it might have to calculate first. So that's essentially doing nothing for us. Unless there is a setting, which there isn't. If there was a setting like, calculate after deformation or something, but there's not. And we could tell this to calculate earlier, but I think the problem is that it's already calculating early. I imagine it's not going to look any different now because it was always calculating first. Now it's still calculating first. Yep. Just solidly shrinks and then solidly grows. There's no energy added to it, which the rest would be doing. The rest effect inside of the cloth, inside of the soft body simulation. Legacy solver won't do anything for us. Nope, 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 nope. Too bad. I mean, it's important to remember that it is a deformer, which fundamentally makes it behave differently than certain other things. Yeah. Let's see. Demi is asking if we're planning any new plugins. I mean, we are trying to get the utility splines out the door. Like I said, I've been actively working on it. I can give you a quick demo of one of the... Here, I can give you a fun little demo of what I think some of the power of utility splines are. And it goes to... The utility splines are not supposed to be like this flashy, sexy tool. Like, they do very practical things. But there's just one of the demos I started putting together for the upcoming videos. And I've been building these demo files, so you'll get these with the tool. But actually, it's in this other folder of the practice ones. Okay, so I'm sure everybody... Actually, how far can we go through this entire process? This will kind of be like a practice run for me. So here's Photoshop, and... Here is a picture I just pulled off of Google Images. Oh, I don't want that one. Oh. Apparently I only saved one of the images. Well, anyway, I'll pop it open. So I just searched for like, or I think I just Googled the word ornate. And you know, like in Photoshop, we could go and do a selection. So I can do like a wand selection and select everything around, grab all this different stuff. And if we did a really nice selection, you know, if you carefully did a nice selection, you go into paths and then we can create a path, but you get very few options. I think, you know, you can do some tolerances and some sampling and whatnot, but you're going to end up with kind of like this really kind of janky detail where you're going to get a lot of like this stepping effect and all these. So anyway, this is not the one I'm demoing, but you can see kind of where I went there. So now inside of Cinema, I can open up, is it Ornate 2? Yeah, so now I open this up, and you can see this time I actually did it from a mirror, but you know, exact same idea. And you'll see the exact same problems happening. If I zoom in, you can see that we're getting that stepping effect and things shooting all over the place, and you would just lose a lot of detail in Photoshop if you try and clean it up. So now I'm going to select all, let's clean it up a little. Let's put it 0, 0. It's pretty small. We'll just deal with that. It means the numbers will be a bit smaller. And anyway, so we got all this extra geometry. So I could go and grab the utility splines and start out with a reduction. So I'm going to drop this in as a reduction. Now, something that's cool is in the spline, I can click on, we got these tick marks, so I could click to show it, but you can also just double click on the icon and it's going to show like, okay, here's exactly where the points are. So currently we're in deviation mode. I don't want deviation mode quite yet. I'm going to go to optimize. And essentially what optimize is doing is it's looking at all of the existing points and it's moving a certain distance along. And then once it's moved a certain distance away, it's like, okay, what would the next point be? It's behaving a lot like the optimize inside of Cinema. So we don't need this to be too strong. But if I start lowering, even just like 0.1, look at the difference here. We are, if I turn this on and off, you see we get all these crazy zigzags and we're kind of eliminating those where there was like almost too much detail on them. So we could even go small, further like 0.2, and now you can see that's gotten rid of a lot of the kind of the jagginess that we had around here. So then I'll make a duplicate of that reduction and let's feed the result into there. And this time I'll say, let's do a deviation based reduction. And essentially what deviation means, and like I said, we're really small right now, like a cube is huge. But this is saying like from this point to this point, does a midpoint move more than 1 unit away? So I'm going to shrink that to a small number. Let's say like 0.1, even like 0.05. No, I think 0.1 is pretty good. 0.1. So now you can see that we've reduced this even more. So if we go back to the original spline, you can see that, you know, it's like it still looks kind of the same. Like it doesn't look too different, but we've gotten rid of tons of points. And we can actually click on here and see the original spline had almost 7,000 points, and then the first one reduced it down to only be 20%, and the second one we've reduced it down a further 28%, so we're down to only 403 points. But anyway, from here I might do something like resample it. So I'll make another utility spline, and we could say resample. I'll drop that in. And now that we've got that resulting information, I could say I would like to step along the process. So obviously we want to be pretty small, so I say like 0.2, and I can see it's like making a point, 0.2 every step along the way, but it's that cleaned up line that we already reduced. Now 0.2 is a little extreme. Let's say 0.5. Yeah, so it's giving us an okay sample. I can also say maintain the original points that we were inputting, so we still get these sharp corners. So now we've reduced that, we've resampled it, so we got a little bit more information if we want to. So now I'll feed that again. I'm overdoing it with a bunch of different splines, but kind of showing it step by step. Now I've got something called Bezier. So we got the Rocket Bezier spline. And what this should do is it's going to attempt to convert this spline into a Bezier spline. If I double click, you can now see that here's the actual points that we're going to be returning. And you can see that we've suddenly reduced this to like 1 point there and 1 point there. All these in-betweens are gone because the Bezier is attempting to convert it. Now what I would like to do here is I want the tolerance to be way sharper, so I'll set that to like 0.2. So you can see that it's only allowed to deviate a little bit. So what that did is it brought back these sharp corners. And then you'll see here that it's kind of doing a broken tangent right there. So I'll say in order to break the tangent, it has to have like 2 straight edges, the tectonic corners. I click on that, you see those will become straight lines. And now we can find the sharp corner. So here's our break tangent. So I can like pull this until, yeah, there we go. You see like right here, look at the input we're getting. You see how that's a really sharp corner, but then look at this overall one here. That feels like it's pretty smooth, but that feels sharp. So let's try and find the threshold here by dragging this up and down. And then you see right there, it's finding those sharper tangents and breaking them. So there we go. Now I can zoom out and take a look at this, and you can see where our points are. So just for fun, let's duplicate that, make this one editable. And now you can see how pretty dang similar those two splines are. But here is the original one. Let me go to point mode. You see all these little subdivisions, all these points, like 7,000 different points. And now we select the one that we've modified, and I can select all of them. And now you can see we've got like nice clean tangents, everything rounded out everywhere, just reduced everything as much as we could. So yeah, lots of power there, even just mechanically using the splines. None of that had anything to do with like the smoothing, which is the main thing I'm usually showing. But being able to like clean something like this up and have the profile be so similar to that original one and reduce it down as a Bezier, I think is really fun. So yeah, this was kind of a practice demo I've been putting together. And yeah, even for the, there's so many different things to do. I mean, and we could keep on reducing this. You'll start losing fidelity. If I double click here, bring these back again. Currently our tolerance is at 0.2. So we're saying like, oh, if it gets a little bit away from where it should be, like, create another point. But if we start increasing this, then, you see we start losing some fidelity, like the shape is going to start being lost. But look at how, like on a nice smooth shape overall, look how this big oval part has now reduced to like 6 points. We got like 1, 2, 3, 4, 5, 6. Like that's now 6 points out of like what, like over 2,000 probably originally. So you definitely have options as far as like reducing. Like, I could reduce this all the way down to like this crazy like double teardrop because we've said, hey, we don't care about all that super detail. But yeah, when you get the right balance on there, then we can super clean it up. Anyway, just a little demo of some of the other power of some of them. Because I know in live streams, we often talk about smooth, but things like the resample and reduction and Bezier are really useful. Cleanup is one that like I do like, but it's only for very specific circumstances. I guess while we're here, why don't I show you? What's a good way of showing this? If I, what's a better silhouette? This isn't a great silhouette here, but well, anyway, I can do it this way. There's a really goofy workaround, but you can see we've got all these subdivisions here, so I can subdivide more. And now, let's make it editable, and I'll do a loop selection, UL. And actually we can do, I'll just do it manually. So I'll select a bunch of these outlines. So we've got the outline. I'll even hit UM. Yeah, path selection. I'm going to say free path, yeah. So, oh no, I don't want free path. I want live path. So now I can go and, draw whatever kind of crazy lines. You can imagine drawing that like circuit boards or some sort of cool stylized, line work. So anyway, we got that. So now, we could convert that to spline, or I could, of course, right now say store the selection and create a mesh to spline, which is another one of our plugins. But now I can say, hey, limit that to a selection, and the selection will be that selection tag. So you can see that it's converted it over to this. But if we were to make that editable, you'll see that we get all of these extra points, which makes sense. Like those exist. You probably want those. But what if you don't want those? If I were to extrude this, and let's say run a dynamic simulation on it, if I extrude this, we get all this extra geometry, which is visually pointless. It does nothing. If we were running a simulation or something on it, maybe. But if this is just a collider body, or if this is extra geometry, some texture extruding, then obviously this is a bunch of redundant information. Anyway, the whole roundabout point of this is if I feed that spline into the cleanup, it's going to remove all the redundant points. So what this does, it gets rid of things that are short on a certain length, and it removes all the redundant points, just as a nice simple go-to. So it's like a safe thing to throw things in. And if two points are directly on top of each other, which can actually cause a lot of problems, this will get rid of that as well. So anyway, just a nice way of cleaning that up and reducing it in a super duper clean way. But then, feed that cleanup into a smooth, and let's subdivide that a bunch. Say that is a step. So now I am subdividing a whole bunch of times, and now I can start adding some smoothing in, and I can round out all of those lines. And yeah, creates a lot of opportunities, considering this is all just based off this, parametric. So we could always just go back into the original spline here and do some additional selections. Select here and update, and now those update, and they get fed through the entire system, and there they are. So yeah, pretty fun. Anyway, just wanted to throw out some thoughts I had on it. Okay, looks like Paul has a question that people are interested in, which is actually a question from Scott. They put in the Slack channel. Mute. I know that he had, in the Slack channel, he had said that there were some specific effects. Specifically starting at 18 seconds in. All right, let's see. So this is a Houdini tutorial. Hang on. Wait for the ad to finish. Skip. Okay. So we don't want to go too far here. Settings are way up. It's a little low resolution looking. Anyway, let's come back to 0. Well, anyway, this is a Houdini tutorial from Nick Meduka. Cool. All sorts of weird string explosion things. So we got some string, more string, and you said specifically right around now. Okay, so we're mostly looking at just a string, just looking at a string explosion. Well, here's the problem: do you remember this is an incredibly similar question to the other one we were tackling, and unfortunately, it has the same limitations, which is this needs like advection, and we don't have advection. Like the things like fume and X particles have things where it creates like heat maps, and there's like areas that are cooler and warmer, and here's a particular flow direction, and we just don't have that in vanilla cinema, and that is what is driving that. So if you had a whole bunch of threads, in theory we could have those exploding and drifting out and doing that type of thing, but we don't have that, and we don't have field forces inside of cloth. We don't have field forces inside of the rope, more specifically. So even kind of the ways I'd go about faking that aren't immediately jumping out at me. So even though, like, yeah, really cool animation and really cool effect, I'm just not super feeling it as a... The base of the thing that makes it look so cool is a particular type of almost like turbulence that we just don't have. Trying to think of any way around it. I wonder. It's not actually. This is not the effect at all, but it kind of made me. And well, what I want to do is wrap a spline around this shape, which of course means I want to. The need would be for another one of our plugins, which is not something I'm trying to do here. I guess I'll throw it out there just for anybody who doesn't have a plugin. Doesn't have one of the plugins. Although, a great way of supporting me in Rocket Lasso is to get one of the plugins. But anyway, if you want to like wrap a string kind of randomly around here, there are like ways of doing it. If it's a sphere. So the most basic thing I could do is make a null, make a second null, move the second null away from it to whatever distance, and then add a vibrate tag. And you want this to like rotate like a whole bunch, like I'm going to say like 3,000. So like this thing can really rotate, but it's going to be doing it really slowly. And that still might be super crazy fast. No, that's not too bad. But we have to have it at a pretty decent speed. Or we need it at a kind of consistent speed, because then what we do is we select the outer null, go to the beginning, and create a tracer. And now as we hit play, that null is slowly traveling around the entire outside. Depending on your resolution, we could speed it up, but then you're going to get like a lower resolution on your spline. But we can have this thing circling, and you could essentially, we'd have to let this go and spin and spin and spin and spin and spin randomly, and it's going to slowly wrap this thing up. So keep in mind, you could do that when this is all said and done, and we have to let it play through tons of timeline. And like I said, we could, let me speed it up. I'll make it go 10 times as fast. And it might look okay, but do you see how like the line is starting to get like a little chunky here? It's on that same subdivision. So it depends on what you'd want to do. But you can see that you could go a little bit quicker here. But anyway, the whole thing's wrapping up. It's interesting, we keep crossing that pole. So we probably want this null to be in a null that had a different rotation so those don't repeat. But anyway, you can see how that's wrapping up, and you could make your tracer editable, and then we'd end up with this spline. Anyway, that is the not plugin way of kind of making that shape. If you do want to support Rocket Lasso, you can get Ricochet, and then we can put this up here. And just line that up, and this is the laser thing, and I can say, hey, look at the sphere, and I want there to be a shell on the outside. So now that laser is trapped in kind of a invisible shell on the outside. You can see it's trapped in between the orange dot and the blue dot. So it's trapped in there, and I can say, okay, align with the surface, so it's going to make nice smooth lines around, and I can just keep on cranking up the length. So now you can see that I was able to pretty instantly make the same effect that we'd have to let the tracer go forever. And the best part here is I can say, make it 10 times as long, and I could be like, make it 10 times as long, and now this thing has been like super duper wrapped up over and over and over again. So anyway, throwing that out there. Anyway, what I wanted to test is just, now I've got the spline, I've made it editable. And what I wanted to do is, can we deform the spline from the surface using a surface deformer? Or maybe a shrink wrap? I think it'd be a surface. Can we deform a spline with a surface, initialize, and let's see, we can probably prove it pretty quickly with a bend. Okay, it is deforming, it does seem to be deforming the spline. So that's a good sign. You see how the spline is bending, wing, wing, wing. So anyway, the theory now would go, we could start running some cloth, and the spline comes after, and we say, okay, cloth, you're going to be super bendy, super stretchy, and don't tear. Tearing would not work here. And then we make a turbulence or something. Turbulence, give it a bit of scale, give it a decent amount of power, hide the sphere, and then we just see the spline. And, oh, I should go to CPU. Whoa, and we should turn off gravity. Okay, so that's sort of doing a thing. The spline is linear If we change it to subdivided, which is what I want it to actually be, the surface, it needs to be made editable for the surface deformer, I'm assuming, because it's something that needs to be initialized. So potentially we could put this on like a B-spline and then change it to subdivided and tell it to go like every 5. It's always a trick to get that to become real. Let me show you what I mean. If I select this, you can see that our point count is surprisingly low. Like there's not that many points here, which is actually bad for our current case. We want there to be more points. But I told it to be a B-spline, which is really smooth, and subdivide every 5, which should be a lot more points. Can we bake that down? There are ways of doing it, but I can never get it to like work right away. If I put that into a connect and make it editable, it's still, the connect did a good job and didn't bake it down. There's a difference between like a spline and a line. This is a spline, but a line is the baked down spline. We maybe can put in a mask and make that editable. Nope, not quite. How do we trick this? Trick it. How do we trick it? The only way I can think of... Oh, I didn't want to do that. That's not a good technique. It's so frustrating because like what I actually need to do is just put this into utility splines and resample and put a step, and now you can see here that we're starting to get like all these extra subdivisions. Let's even put it a little bit smaller. You see lots of little lines going. I make that editable. Anyway, now I've got a super duper subdivided line. That's the equivalent of taking the tracer and letting the tracer travel slower as it spun around. But now you can see it's actually subdivided more. Super easy to do. Drop this back into the resurface. Initialize it again to be looking at the surface. It's now very subdivided, so it should be able to deform better, which it is. I guess the underlying sphere should also be more subdivided. We can do that. Let's go 124, significant subdivision. Need to reinitialize. See, it's taking longer because there's more points. It's only 1.5 meg though. But anyway, that should have more points, so this should just be smoother overall. You can definitely see the turbulence getting represented now. And we're getting, the lines are bending better and the geometry is bending better. Turbulence is a little small. Let's go 4 times the scale. See the geometry shape a bit. And yeah, now we're kind of getting these, you know, it's kind of like we've got a turbulent surface, but is this anything like that really sweet advection that was happening in the reference? Like, no, not even close. And even here, again, you can see that we're getting all these crazy explosions, or like they're all wiggling around, they're doing it. But even with all those subdivisions we put in, that these are still getting like really janky, really sharp because of just the nature of the geometry deforming. While we've been on the topic a whole bunch, if that goes into a smooth, I guess the utility splines have just been on my brain because I've been preparing demos for it. But I could subdivide it one and then start adding in a little bit of subdivision here, and you see it's going to start rounding those back down again. And because I guess this is a deformer, and then we are linking to that, deforming this, and then seeing the resulting spline, so it's parametric on top of it. So you can see that ours is running after the fact, and like it smooths out all of those lines and fills it out a little bit more. And then we could set up redshift to see this line. I mean, keep in mind this is only one line traveling all the way around. You could, it's going to run slower, probably significantly slower, but instead of deforming that sphere, we'll delete that, and instead we'll go to, let's even delete the resurface. I can go to this original thing and say, you're a rope now, and now these are all subdivided, and, you know, the ropes run relatively quick, but this is a lot of points. I'm going to hit play. Let's just see what happens. It's starting to take a little bit longer than I want it to, so I'm going to pause it. We already were on CPU, so that's not a problem here, but it looks like we might have... Oh, no, it did catch up. There was a lot of intersections early on, and now it did wake up, and it is pretty cool. Even just going one frame, you can see how, like, these are all pushing away from each other, so that's pretty cool. Is it going to be quicker now? After frame 1 is all those initial collisions. Now they're not colliding, so if I play, it's actually going to get decent playback. So all the turbulence is wiggling around these individual lines, which is pretty cool. And then potentially we could even put a tear on there. Put it relatively weak. I don't want to go too far, but I definitely want to see some tearing. 102. Still not really seeing too much in the way of tearing. 101. If I say 100, it's just going to instantly tear. Does that just not want to tear? I feel like we should be seeing some rips. It's deforming quite a bit. Bend. Huh. I really feel like we should be seeing some tearing. Maybe it has to start from the beginning to get the tearing. Because we turn it on later, but it doesn't make sense to me. Yeah, yes, we can. Well, 105, I guess. I just didn't want to restart it because of the big chunk of time it took in the beginning, but, you know, it didn't take too long. Zach is saying that potentially you could fake some of the advection by, you know, growing some invisible spheres, and I do agree. You might be able to fake it a bit, but keep in mind that the spheres are going to be two-sided, and once a spline is, once one sphere passes through another sphere, that spline isn't going to know what to do in between the two, and it's going to freak out. And advection is such a very specific system. Why is this not tearing? Nope. No, there are finally some tears. Okay, so you can see a tear and a tear and a tear. Anyway, what I kind of want to show there with a little bit of tearing, which is, yeah, I mean, this nice fuzzy ball now, which is looking pretty cool. But I think it should work. We should be able to go into smooth here. If we go into spline, we can say that, like, here's just our basic spline, but we could say that I want every segment to be exploded. So now there's like a whole bunch of different segments. And I could say I want to randomly colorize them, and now you can see we get some random crazy colored lines. This wouldn't be a great idea to do for the overall animation because every time there's a break it's going to be generating a new color, but I just want to show that you could colorize your splines. This really kind of fills out the form. So if this was already pre-broken, then they could be remembered, but instantly that's adding so much more than just that black line over, you know, being a silhouette. Let's see, we got about 20 minutes left. What should we try and tackle? I'm not even going to save this file. The whole process was a mess and we were using unreleased plugins, etc. Proxy was mentioning the curl noise in the volume builder, and yes, there is curl noise in the volume builder. It's not the same, and that type of curling noise, it can lead to cul-de-sacs, like almost like a black hole where everything's getting sucked into one particular spot, and it's also not evolving in a way that feels natural. What looked cool about the other advection thing is you can almost imagine like a plume of hot air like blowing up and kind of swirling and twirling around. Like that's what it looks like. You imagine pulling a blanket off of a fire and kind of the swirl of smoke and heat and the difference there. That's what's making it look visually interesting. And we're not going to get that by faking it. Like, it'd be insane to attempt to build a rig that would do that, especially when there are pieces of software that just do that. Paul, let me check YouTube. Okay, no, YouTube doesn't have any new things. Paul asking, how would you rig a winch unrolling and rolling up? I feel like, well, first of all, we've kind of done that. But I guess we do have an all-new system that we haven't really played with to see how well that does. So let's see how that does. Let's even make something a little bit robust. Yeah, thanks for the idea. I like it. So we'll make something that's kind of default sized here. And how would I like to do this? The new simulation stuff it's not a bad idea to have a decent number of subdivisions. Like, it does make it see it better overall. So we'll do that, and then I'll make a child. This one doesn't need all those height subdivisions. Increase the radius and make it nice and thin. Okay, so here's the thought. We're just going to build kind of a giant spool. Whoa there, Nelly. Go all the way back. -1. There we go. Okay, so we do that. I would also like to, maybe ill-advised, actually very ill-advised, let's put a hole through it and do it a little bit more realistically because, well, I don't know a lot about winches. So I'm kind of going off the Lego piece, like the Lego winch. So here's the idea. I would like to make a hole inside of it like that, like the Lego piece had. And the hole was off to the side. And that probably doesn't need that many subdivisions. Okay, cool. So that is our basic shape. I guess we can even leave it parametric like this. That all gets put in the null. And select all, put it into the null. Winch, caps lock. Okay, now we need a piece of string, a really long piece of string. And we're going to need a ground to collide with. Hopefully that works. The ground, I've had trouble with ground sometimes. So we'll do that. We'll even give that a couple extra subdivisions. And we need a nice long straight spline. Go with our old friend of the helix. 0, 0, 0. And what, 2000? Maybe? R. Go with 3000. So 3000, and we'll do 300 points on it. So there should be, yeah, 300 points going along. Move this into, I guess, should we twirl from the bottom or top? I don't think it matters too much, so I'll move it from above. From the top view, we can see that hopefully that is directly, yeah, pretty much directly over that. And I don't know if it's ill-advised or not, but I'll make it editable. And you can see the point count right now, seemingly reasonable. And I would like to continue this spline. How difficult is it going to be? We can go to the pen tool, and I think I can just, like, click there, and then I should be able to, what, hold down control? Yeah, and then subdivide, 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 subdivide. Just eyeballing it. So just a couple extra subdivisions in there. So nothing crazy. So the Lego piece would have a big knot right there. What I will do, oh, this went to dead center. Let me fix that. The axis of this thing is also really far out in space. It shouldn't be. I guess it's, oh, it's selecting the midpoint. If I select the model, there we go. That's what I want. Scale that down to 0. Model-wise, and that should be perfectly flat in the tunnel. Cool. Okay. These need to be, we could make these a compound shape, but I think we'll just spin them all individually. So that will be a collider. Now that that's a collider, we'll make this a rope. And I want to fix a point, but I don't think I want to fix it via, like, just fixing a point, because it's just going to be stuck in space. I would like to belt it, I suppose. Keep in mind that there's a difference between a rope belt and a cloth belt. So we need a rope belt. The rope belt will belt onto the bool, and it is going to be that point right there. That's the only one I want to be done. It might be a good idea to do all of them, but I just want to see what happens. So now with that point selected, I can say set, and yep, you'll see that we get a yellow line, and the yellow line is shooting and connecting to the closest possible spot that it can. Like I say, maybe it goes to the, you know, I think that would be a little bit closer technically, but whatever. Seems okay. Anyway, in theory, that should be connected to it. So, in order to make it so we can actually see things, let's sweep this. Rope, don't subdivide, please. Rope, radius of 5. 5 seems fine. I'll also tell the rope to be a radius of 5. Save the whole thing. Winch, rope. So let's just hit play. Oh, let's first go to CPU. Hit play. Okay, that's fall. We should probably make that a collider, shouldn't we? Boop. Okay, so that falls and blump. Okay, fine. Working just fine. So now we need to spin the winch. So, nope, nope, and yep. So, keyframe that and more frames. Go to the end and spin this way. I don't know how much we want, so I'll say 2,000. It's going to accelerate in, maybe a little dangerous, but let's just see what happens. Hit play. Okay, I thought I spun the other direction, but that's fine. Doing fine so far. Okay, very nice so far. Like, it's behaving pretty realistically right now. That's cool. Oh, and we've run out of speed. Okay, so that's surprisingly good so far. Back to the final frame. Let's go negative 5,000, so more than double the other direction. So we've got, okay, so it's going to go faster. There should be some decent amount of friction on the ground. You see that the rope is actually pulling across quite nicely. Yeah, that coiled up nicely there, and now it's jumped to the next spot. This is working very well. Flap, flap, flap. So yeah, actually quite pleased with this as a mechanical rig, and even that going through the hole and everything seems to be working fine. Who knows? This is even all default settings too. So like we could say that the rope is like way more bendy. We could say that the rope is decently stretchy. Right now the friction is minimal, but you already see that bend a little bit more. More friction could be a good or bad thing. More friction might make it so that it can get tangled up on top of itself more. But you can already see it's a little bit different. Let's see what happens. I'm going to say like way more friction. I just want to see if it can get tangled. By sheer coincidence, it might not. It did go the other direction. But yeah, with lots of friction, I'd almost imagine this could start stacking up on top of itself more, which it kind of seems to be. Yeah, you got a couple nice knots in there before it kind of scooted over to the other spot. Yeah, it's working surprisingly well. I like it. Now, I noticed that Paul said that you were kind of hoping for a non-sim solution. What non-sim solution could there be? A winch? I mean, at that point, you'd have to have something rigged, which probably means a giant joint chain. And like, why would you subject yourself to having to keyframe a joint chain connecting? It's such an obvious use case for a simulation. Let me think. Would there be any... What would I do non-simulation wise? I don't even know what it looked like. I mean, I don't know to what degree that this is a proper winch setup. Like, maybe, but maybe not. Just to be silly about it, I'm going to move this up and line it up. Yeah, this will be goofy. Well, do it here. Don't know how well this will work. It might be terrible. But if I make that editable and make it red, because why not? Make that a cloth, and then we make a connector and say I want that to connect to other objects. Live update. Other objects, live. Okay, now you can see that. Okay, so now what's happened is we've got a piece of cloth, and now it's connected from there to there, there to there, there to there. So it's made a bunch of connections to this rope. So I just wanted to see what would happen. So yeah, let's just hit play. Whoa, we're going up. There might be a good reason for that. Stretchiness, we'll give it some stretchiness. Target length 100. I think it actually needs a decent amount of. I'm gonna give it some extra length. I think the thickness of the. Well, that's super weird. It's like it's connecting to nothing. I mean, it's still dragging it. That's super weird. I feel like it's not super happy with us. That didn't work at all the way I wanted it to. Make it more stretchy. Increase the target length even more. Like, it's still not falling the way I thought it would. Because we still have gravity turned on. A thought is that these connections were like trying to pull the rope, which has thickness, into the cloth really hard. But the way this is drifting down, like, I don't even know what to make of that. I don't have a direction to go because that just seems bizarre to me. Oh, it's also a collider. That's a bad thing. That's a bad thing. Okay, delete the collider tag from it. It's not a it's not supposed to be colliding. There we go. That's behaving a little bit more. Okay, now it's just a piece of cloth on the ground. It should have a decent amount of friction. So that's stretching, and now the whole piece of cloth is getting dragged. Not surprising. It's not very bendy. Okay, working surprisingly well. It could use a couple extra collisions, but it is doing a pretty good job. Okay, I didn't know what to expect, but that was nice. Okay, cloth. Very bendy and decently stretchy. Let's just see what that change by itself makes. Oh, a little bit of stretching there. You can see it folding over on itself a bit. Yeah, there. Now it can actually like wrap around like a piece of cloth. Yeah, better. More subdivisions would be better. Potentially we could make it bend even more. I don't even think it was very stretchy. But yeah, I'm a little lost on bendiness as a concept. Well, it just goes to the numbers feel really extreme. Like, that doesn't feel too different. It's a little different, but yeah, working in a fun way. And then we could change some things like sub-steps. I think more specifically, some collision steps are a good idea. So I tend to jump the collision steps from 2 up to like maybe 10, and then polish iterations, which does make a visual difference. The 2 is just kind of right now my go-to formula. I don't have a great intuition for things. Adding a bunch of extra sub-steps I haven't found helps that much. You can already feel a little bit more like struggle right there. There's a lot of kind of push and pull on it. I'm looking for the rope escaping through the cloth, especially once it starts wrapping here. I gotta say, it's doing a pretty good job. There's a little bit there, but not much. And if we actually gave the cloth a little bit of thickness, like visually, that could, you know, potentially add to it. I don't know. It feels like it's kind of working correctly, right? The extra collision passes definitely feel like they're adding some friction. Like there's more of a friction effect here. So potentially you'd want to decrease your friction to counteract all these collision passes. Maybe, I don't know. But yeah, super weird, pretty fun. A lot of, I think there's a lot of fun exploration to be had. And, you know, we're only just getting started with cloth and rope. Excuse me. Anyway, I guess we only got a couple minutes. Is there a follow-up? Oh, yeah, Scott, following up on my earlier question for the non-sim solution. And yeah, I guess you're right that the only, if you're not going to do, if you're not going to do simulation and you don't want to do joints, then I think the only option does go to like a bend deformer. And then that always goes to a tricky thing with the bend deformer. Let's just, I guess we can close on that as a final thing. I want that straight to spline again, just so we're pivoting from the correct location. 0, 0, 2,000. 200. None. Okay, so if we make a bend and we... what orientation? Probably this way. And we're going to deform... Well, let's actually put that into a null. Because what we're going to do is take this bend, which should be probably 1 by 1. No, 1 by 1. So now it's really small overall. And now I can say, okay, now bend. So you can see it's bending around just fine. So the spline is bending, and I can independently move it. So you can see I pull it in here, and it's going to spin around, and then it would just continue its way outward, and it just keeps on going out. So we got like a nice little curl in there. If we change the bend to unlimited, then the whole thing spirals both ahead of it and behind. It's actually looped on top of itself a bunch. So then we can try and use a field. That's weird. I guess it's not weird, but still, maybe it's weird. I don't know, throw me off a bit. Y plus, in this particular instance, pinch it down. Okay, this is a little bit more what you wanted. If I move that back, there's a little transitional space, but the main thing is this going to curl around. Okay, yeah, you can see now that as I pull this through, it's going to curl around, and it goes around and around and around, but it's not affecting the other side, which is good. So then, let's have it actually spin around a few times. So then we take our overall bend, and let's make linear not a child of it, because I want to rotate the bend a little bit. Now, if we physically move it up and down, nothing will change. If we move it in and out, I think we change, I thought we changed the radius. Wait, linear field out, please. Bend. There we go. Yeah, if we move it up and down, nothing's going to change. If we move it in and out on X, the radius will get larger and smaller, as expected. And this is just the position of it, so that's not going to change much. But then we can start changing the rotation of it, and that's where things might get interesting. What's our best axis? I'm not even sure. If I bend it down, you can see we're going to start spiraling away just a little bit. And we can do the same thing on Y. It's going to... Well, I thought Y would do it as well, but Z probably will. Yeah, so if we go Z, you see it will tighten as it goes, which is pretty cool. Just to show you, if we grab the original spline, I should be able to pull it out. And you see, as I spiral, it's actually going to go and twist in and in and in and get tighter and tighter and tighter. So it's, you know, that's a cool effect to do. I've got a peeling paint tutorial. Let me see if I can find that. Rocket Lasso peeling. I guess it's probably paper, not paint. Yeah, easy enough. So we get this paper curling effect tutorial, and I go through all of this in like pretty extreme detail. So I'll put that in the chat. But anyway, so that is if we rotate it on one axis. But if we rotate it on, was it this one? Nope, it was this one. Now it's actually spiraling down. It's actually spiraling slightly at an angle. So you want to go really easy on it. But now as I pass it through, we've kind of got the winch spinning, and you can see that it's going to keep spiraling downward. And what's cool is we can even go beyond it, and you'll see it'll keep on like spinning down. So I think it's going to be kind of traveling along a cylindrical shape, but keep in mind it's probably at like a 2-degree angle or something now. So you'd want to probably counteract that somehow. So yeah, this would create that nice spiral for you. You've made a lot of effort for yourself. But I think it would work. You're not, I mean, obviously the simulation gave us so many things for free, like it coiling up and offsetting and not colliding and being able to wrap up on top of itself, travel into the wall and then suddenly start traveling back the other direction. Like a lot of things just worked well, but this would be the only, this is the only other semi-simple way I can think that you could possibly do it. Winch bend. So save that one. For anybody who doesn't know, all of the scene files I've been saving will be available on Patreon after the show, usually on Friday when I post, sometimes a few days after. Just throwing that out there. That puts us pretty much on the money as far as time is concerned. Thank you for the excellent questions. It's always fun tackling. We did a lot of simulation stuff. Everybody's really on the Advection train. We might have to looking into that as a different system. The I'm trying to think. Well, it's just not when it comes to like that type of what do you call it? Well, just like smoke and fire sim. It's not something I'm super familiar with. I've tinkered with it, but I haven't done a ton of it. So I'd have to spend time learning on my own. Anyway, checking the chat, see if there's anything else. Iron Sight was mentioning maybe a spline wrap on a helix. You might be able to do a similar idea where you do a spline wrap and a fall off and you pass it through. And something to keep in mind with spline wrap is the spline wrap it automatically makes a bounding box that puts it around it. But you could tell it to automatically update the bounding box. You can tell the bounding box to be manual and be static. So at that point, I think you could pass into it. I don't know if it would improve this circumstance at all, but that would be something you could do. Phil's asking if I post Twitch VODs. I think it might be available directly on Twitch for a little while. I post the replays on YouTube. I've got an entire channel for it. So if you're not already following it, well, here, if I pull it up on here is the Rocket Lasso channel. If you just go to Rocket Lasso, so YouTube/Rocket Lasso, you'll go here. And when you go to, I guess I'm signed in here, but when you just scroll down a little, you'll see live stream archives. And if you click on that, it's going to go to the other channel. So here's the replay channel, and here's just all the episodes like in full, and it's 4 seasons of all of the episodes, and I put a bunch of work into like the titles and the descriptions and time codes on all of it. So but yeah, that's all there and all available for replay. The stuff gets posted a little bit earlier on Patreon, but not much, like maybe a week. Anyway, that should wrap this up. Thank you so much everybody who purchases any plugins from Rocket Lasso, and I appreciate the subscribing on Twitch. That's a nice way of supporting, and of course the people supporting on Patreon. It's super valuable to us to be enabled to go and do this as a business. So thank you so much everybody. I will be doing another live stream in a week, of course, and keep an eye out. I don't know exactly when, but the utility splines are coming soon, and you can see like my brain is stuck on utility splines. So that'll wrap this up. Thank you so much everybody. I will see you next week. Goodbye.